So chemical equations are what we use to represent chemical reactions. In math, we have equations that represent things that are going on. And a chemical equation is a lot like a math equation. So we generally have substances on the left, and then instead of an equal sign, we use an arrow, and we have substances on the right. On the left side, these are the reactants, and on the right side are the products. So here we have the reactants, and here we have the products. And the arrow indicates direction. The reactants react to produce the products. The physical state of each reactant or product is often indicated in parentheses. And so we see here G for gas, G for gas. Actually, all of these are gases. It is often indicated, not always. We usually only put it in there if it's significant. Sometimes we care, sometimes we don't. But that's what the little things in parentheses mean. So G is for gas, L is for liquid, S is for solid. AQ means aqueous, meaning it's dissolved in water. It's a little bit like the word agua. Aqueous, dissolved in water. When something is dissolved in water, it's a mixture and we call it a solution. And we'll talk a lot more about solutions later. So let's look at this chemical equation down here. And here are some pictures representing what these formulas are showing. So here's CH4. The carbon is black and the hydrogens are white. And then we have oxygen. Oxygen is one of those diatomic elements. Remember, horses need oats for clear brown eyes. So when oxygen is by itself, it's always O2. So 2 oxygen atoms there. And then those are going to rearrange and recombine to form carbon dioxide and water. So here's what a carbon dioxide molecule would look like, and here's what a water molecule would look like. Now, if you had these actual models in your hand, could you take these two apart and make them into this? No, because over here you've got 2 red balls, and over here you've got 3 red balls. Can red balls just come out of the air? Can Legos just appear out of nowhere? Not really. And then over here we've got 4 white balls, 4 hydrogens, and over here we've only got 2. Does that mean that 2 white balls turned into 1 red ball? No. Atoms cannot be created or destroyed in a chemical reaction. What this tells us is that our equation is not quite right. We've got the formulas correct, but not the numbers of them. We can't have atoms appearing or disappearing. So here we're examining the hydrogen problem. Here we've got 4 hydrogen atoms, and here there's 2. They can't have just disappeared. So we need to balance this equation. And the word balance, I think, is a great word for this, because you can imagine that this is a teeter-totter. And you've got the reactants on one side and the products on the other side. And you have to have the same number of white balls and red balls and black balls on each side of the teeter-totter for it to be balanced, right? This one's not balanced. So how do we balance it? Well, if we started out with 2 oxygen molecules and we ended up with 2 water molecules, then we'd be okay, because now we've got a total of 4 red balls, and over here we have 1, 2, 3, 4 red balls. Here we started with 4 white balls, and now we end up with 4 white balls. We've got 1 black and 1 black. We have the same number of atoms of each element on each side of the arrow. We started with 4 hydrogens and 4 oxygens and 1 carbon. We end up with 4 oxygens and 4 hydrogens and 1 carbon. What has happened is they've just been put together differently. So it's like you took some little tiny Lego creations, you took them apart, you put them together in a different way, and you used all the pieces. There's no pieces just left over. Any questions yet? We have to really understand this picture concept of what's going on, because we're going to lose the pictures pretty soon, and you have to be able to kind of picture it in your mind. Everybody okay with this?
Well, what I'm having, how do you know what to mix what with?
How do you know what to mix what with? Okay, so you're going to have to do that very, very minimally, and I'll teach you how to do it before we do that. Yeah, you're welcome. Because at this point, yeah, so why CH4 with oxygen and why CO2 and H2O? Well, these things are determined by observation. So this is actually what happens when natural gas burns. Natural gas is mostly methane. When methane burns, it reacts with oxygen, and we know that from observation. Reacts with oxygen, and the products that are formed are carbon dioxide and water. And so how do we know that? We know that because we observed and we measured and we figured out. It's nothing that's just, oh, well, yeah. There's no better explanation than that.